Okay. Hello. This is Directive 4.3, where we are going to solve problems about similarities. So everything you've learned about stuff being similar is relevant here, and now we're just like applying it. So it's like problem solving, right? So put on your little problem solving hats, right? Just like, oh, okay, he's trying to wish you well. And he's got his little problem solving hat is little bumblebee hood. Yeah. Okay, wish you well. All right, here we go. So, first, start with vocab as always. So similar is two triangles, or two shapes, which are two triangles, right? They've got congruent angles and proportional sides. Okay? Congruent is different. That's when we got two shapes, so two triangles that are the exact same size. So notice similar is the same shape, different size, ends up with congruent angles and proportional sides. Congruent is the same size and shape, so all pairs of angles and all pairs of corresponding sides are congruent. Scale factor is the ratio of corresponding sides. That'll kind of tell us like the factor of dilation, like the size of the dilation. Are we enlarging or are we shrinking? I might want to write factor of dilation if you want. I'm going to say somewhere in that really small, sorry. Okay. A ratio is like 3:1 or 3:1 or 3/1. It's just when we compare two values. Parallel means we see that never intersect. So like if we've got two lines, we want to say they never intersect, remember we can add those caret markings. Vertical angles are going to come up here where we're going to, that's when two lines intersect, and those angles, that's going to create like four angles, and then the two sets opposite of each other are going to reflect on each other and be the same size. So vertical to each other, and then these angles are vertical to each other too. And then a proportion is just when we have two equal ratios, right? So like 1/2 equaling 2/4. We got two ratios. Sorry, different numbers, but same quantity. Okay? So what we're going to figure out here is, again, we're about problem solving using similarities. So I'm going to show you a different problem solving strategy that involves something called proportions. We kind of explored that in class today, but we're going to skip over it for now and jump straight to our key points box, where we're going to say, because the ratio of sides in similar figures are equal, we can use a proportion to find a missing value. So again, this is when we have equal ratios. Okay. So let me show you how to do that. So, for example, if we have triangle CAB being similar to triangle FDE, and we want to find X, right? So we know the corresponding angles are the same. That's already marked. And we know our corresponding sides are proportional, right? So that means if the corresponding sides are proportional, that means like AC divided by DF, right? These are corresponding sides. I can see that because the triangles are shaped the same way, but I can also see it using my similarity statement, CA and FD. So AC divided by DF should equal CB divided by FE, right? And here we're not told if this is an enlargement or a reduction. We don't know which one is the pre-image or image, so it doesn't really matter the way we're going to divide. Okay, we just know that the ratios of the corresponding sides are going to be equal. That's what proportional means. So if I have this thought, then that's going to allow me to set up something to solve for X. So instead, what I can do is basically fill in AC, which is 21, DF is X, CB is 27. FE is 18. And now this I can solve by cross multiplying. So cross multiplying is, if you've seen this like butterfly thing, where you can say 21 times 18. So I multiply the numbers like diagonal from each other. And then x times 27. So then I'm going to get 21 times 18 is 378. That's equal to 27 x's. Divide by 27. Divide by 27 and get x equals 14. Okay, and I can test whether or not that makes sense by dividing. If I go 21 divided by 14, what is that? Okay, it's 1.5. 27 divided by 18. Is that also 1.5? Yup, so we know those side lengths are proportional. X has got to be 14. Okay, so maybe a note that you want to write about proportions is it's like, let's say I have A over B equals C over D. The way to solve that is A times D equals B times C. That's the way you can like kind of solve for that, okay? And here, listen, we could have used the scale factor, but I'm going to show you an example here where like you can't, it's harder to use scale factor and it might be easier to use proportion to solve. So we're going to find x and y such that triangle ABC is similar to triangle DEF. So again, those side lengths got to be proportional. So let me find y first. So I like to kind of start with what I'm trying to find. So y corresponds with DF goes with AC. I'm reading from the similarity statement. So I like to even code them. So DF goes with AC. So y divided by 18 should then be equal to two other sides being divided, two other corresponding sides being divided. Let me figure out my rest of my corresponding sides. So AB, I'm going to put a little box around that. That goes with DE. Similarity statement is telling me that. And then 4x minus 1 then must go with 10. Okay? So I'll set y over 18. Y over 18 equal to 6 over 9. Now notice, it doesn't make sense if I'm going to go y over 18. If I'm going to go DEF over triangle ABC, my next number up here has to also be from DEF over ABC. I can't switch the 9 and the 6. Okay? And another thing to note is that it doesn't matter how you set up the proportion as long as your first ratio matches your second ratio. So let's say I decided to put 18 over y. That would mean that I'd have to put 9 over 6. If I said 18 divided by y, then I would have to go 9 divided by 6. Okay? So then I'm just going to cross multiply these, right? 18 times 6 is 108. It's going to equal 9 times y, 9y. So I'll divide by 9 and get y equals 12. If that helps, I'm just going to write it there. Okay? Cool. So now let me do the same thing to solve for x. So x is side BC. So let me say 4x minus 1. BC goes with EF. So that's 10. And then now I'm going to write 9 over 6, not 6 over 9 because I started with triangle ABC in the top. And then I'm going to cross multiply again. So notice the cross multiplying here. When I multiply 6 times the 4x minus 1, I have to multiply 6 times that entire group. I'll use parentheses to help myself see that. That's going to be equal to 10 times 9, which is 90. So now I'm going to solve 24x minus 6 equals 90. I'm out of space, but I know I got to add 6 to both sides. You're going to get 24x equals 96. 96 divided by 24 equals 4. And again, I could do the division of all of this stuff and all the corresponding sides and make sure the scale factor was the same if I want to check my work. Okay? So x is 4, which would mean this side length is 4 times 4, 16. So that would make this side length is 15. Okay? So we've got some light practice problems that you'll be doing to practice that. Now we're going to move on to a few more examples of proportions. Okay? So similar triangles are really cool because they show up like all over the place in real life. So we're going to see a few examples of that. The first is this situation. In a certain park, the layout of the 6 bicycle paths shown is in the figure above, it's below. The length of PQ, QT, QS, and SR are 3, 4, 8, and 10 miles respectively. Okay, so it's giving me the lengths in those orders. So I'm going to label my diagram. PQ is 3. QT is 4. QS is 8. And then SR is 10. Okay, past PR and ST, so PR and ST intersect at Q. I see that there. Okay, ooh, and I'm seeing vertical angles here, so I'm going to mark those congruent, right? Like when we saw in the vocab. Those are some intersecting lines right there, forming congruent vertical angles. And then it says TPQ, so TPQ, so this angle is measured to, is equal to QRS. Okay, so bam, bam. All right, what's the value of M? Cool. Well, hey, I'm seeing right here that I have 2 similar triangles because they have 2 angles congruent, so they are similar by angle. All right, now, the next thing that I would do is when similar figures are drawn in a connected picture, it might be easier to redraw them separately with the same orientation. Okay? To help yourself, because like where we're going to make mistakes here, guys, is like if we're not matching up the stuff that corresponds. So, that would mean that if I redraw maybe this as PTQ, where I'm saying PT is M, PQ is 3, and QT is 4, right? I'm going to do the same thing. Sorry, my bigger triangle, woof, is this has got to be Q, because these 2 angles go together, right? And then this would be S and R, right? Because R and P go together, so they got to show at the top, then S and T. Cool, okay? And then, so maybe we'll even just show whatever, that these are the same, okay? And then RS is 10. QS is 8. Cool. And so now we want M. So now this becomes, honestly, you can see it pretty easily just by scale factor, right? Like you can see that it's been doubled, right? From 4 to 8 is times 2. So then 10 to 2 is divide by 5, or divide by 2. So M's got to equal 5. You could also set up that proportion, right? You could say like M over 10 is going to equal 4 over 8. Sorry, M over 10 is going to equal 4 over 8. And then you're going to get 40 equals 8M. And when I divide by 8, I get M equals 5. But again, this thinking, it gets way easier to see what stuff matches up if you just redraw the picture separately. Otherwise, you should be doing some type of marking on your figures to see that, like, you know, the 4 and the 8 go together. They're both across from the same angle. Therefore, this and this got to go together. Okay. All right. Last one here. The next one is in the figure below. AE is, oh, hey, parallel to CD. So let me draw that. Cool. And segment C80 intersects segment C at B. Oh, look, noticing vertical angles here. Sweet. What is the length of CE? Okay. Oh, hey. Something I'm noticing here is if I imagine extending these lines, and then I'm noticing this here. Y'all remember what this is? Oh, hey, it's a transversal. All the relationships about parallel lines cut by a transversal still apply, right? So remember when we had parallel lines and a transversal, remember if like this was 80, that would be 100, that would be 100, that would be 80, and then this intersection below it would be identical. Translate this intersection down here if these lines are parallel. Okay, so that's going to help me see what stuff corresponds, because here I got alternate interior angles right here. So this angle and this angle would have to be the same. They're the angles in those 2 spots. in the transversal, if it helps. I'm going to highlight. These are my parallel lines. And if we're looking at the yellow transversal, parallel lines, yellow. Okay. And then that must mean that these are the same angle. So cool. I know that I've got similar triangles by angle, angle again. All right. What's the length of CE? Ooh, so what's this whole length? So I want to know what CB is first. But again, I'm going to redraw the pictures with the same orientation to help myself more easily see this. So this is CED. So I'm copying this triangle there. I want to know this, so let me call it X. And I know this is 5. And I'm going to redraw the other triangle going the same way. Where now B's got to be on the bottom. A goes with D, so A is there. E goes with C, so E is there. Okay. I'm going to copy my congruency symbols too, because that makes me feel better. C goes with E, and then A goes with D. Cool. Okay, and then BE was 8. EB was 10. All right, sweet. So then, hey, this might be another, again, this is pretty easy if you see that it's just been doubled. So 5 to 10 is 2, so 8, that's got to be 4. You could also do your proportion, right? So 10 divided by 5 is going to equal 8 over x. So you could set up that proportion however you want. And then 10x is going to equal 40 divided by 10 x equals 4. Cool. Now that doesn't answer the question because I want CE. So I did that to find that this length right here is 4. So then how do I find CE? CE is going to be equal to this 4 plus the 8. The answer is 12. Okay. So like I said, this lesson is all about problem solving, guys. It's like seeing similar triangles in different contexts. Okay. All right. Hope that made sense. Lastly, we got similarity in context. So in some more real life context. So, for example, if we've got Jacob being 130 centimeters tall, his shadow is 100 centimeters long, and the shadow of a building is 200 centimeters long. How tall is the building? Okay, this is like a really short person and short building, but maybe we're talking about models here. Whatever. Okay, so, this is a situation where, word problem, I'm going to draw myself a picture if one is not given. Okay? So, I got Jacob, and I might I'm going to draw myself like, hey, a little stick person. So we got Jacob. He's 130 centimeters tall, right? So we measure height with like a vertical distance, right? So that's 130. Now his shadow, think about your shadow. Your shadow falls off the floor in front of you as like a horizontal line. So his shadow is 100. Okay? And then notice what this forms here. This forms a little right triangle, right? Now we got a building. So draw myself a little building. Yay. I don't know. Draw some windows. I don't know. This is a terrible building, but you get me, right? Okay? Whatever. Okay? Notice, the thing to notice is that the height of a building is also a vertical line. Okay? And so, how tall is the building? That's what we're trying to find. So I'm going to call that X. The shadow of the building is 200 centimeters. So, again, your shadow falls flat on the floor in front of you. So that's a horizontal line. Look, another right triangle gets formed. Right? And these are situations that are going to be similar. So, super easy. I can notice again that the thing is doubled, or 100 to 200. So 130, it's going to have to double it. Or I could use my proportion where I go, I don't know, 130 over X equals 100 over 200. And notice, guys, I'm like purposefully setting up proportions different ways to show you there's flexibility with that. As long as you pick corresponding sides. This over that, that over that. Or you could have done that over that equals that over that. Okay. Then I cross multiply. Right. You're going to get, when you do that math, you're going to get, what, 130 times 200? Well, 130 times 200 is 26,000 equals 100x. So divide by 100. You'll get x equals 260. Cool. Okay. Okay. Next example. We're going to actually pause. I'm going to pause on these two examples. I think these two you can try on your own and in class. This example is very similar to what you just did, the other one in the last problem, in the last key points box, right? And this is kind of a challenge problem, that stretch that I kind of want to see if you can do on your own. Okay, so we will pause the video here. The main thing I wanted you to get out of this key points box is if a picture is not given, draw one. Draw one and see if two similar triangles get formed. And then use your pictures to solve for missing info. Okay? That's it. Hope you enjoyed.